Today we're looking at slope and rate of change, part 2. I think just continuing with slope. The first part of what we're looking at today, we've looked at previously. Let me focus that a little bit. Choosing your slope formula between 2 points, like we talked about yesterday. Then also a little refresher talking about finding slope from a table. Just change in y divided by change in x. That is no different. So here our change in y would be down 3. Change in x would be up 1. So negative 3 divided by 1, and we get a slope of negative 3. If you look at the next one, that change in y is up 2. Change in x, up 1. So 2 divided by 1, we get a slope of 2. Next 3 are the same. We just have the tables are represented in a vertical direction. Everything else is the same. Change in y here is up 5. Change in x there is up 2. So 5 over 2. And we leave slope in fraction form. Do not convert that to a decimal. Change in y on the next one would be up 3. Change in x, up 1. So 3 divided by 1, you get a slope of 3. And then that last example, change in y is down 10, 30 to 20. Change in x is up 3. So negative 10 over 3. And you cannot reduce that fraction. So that is our answer. So that was just a refresher on finding slope from a table. Next, we're going to look at something called unit rate. Unit rate is a rate where the denominator of the fraction is 1. In other words, we're going to be given a situation in different units, and we want to find out how much would it be per 1 unit. In other words, if we look at number 1, says a car travels 110 miles in 2 hours. Find the unit rate. In other words, we want to find out how much it'll travel in 1 hour. So all you're doing is dividing. 110 divided by 2, and we get 55 miles per hour. That should be your unit rate. The second one, if we had 4.5 pints and 3 servings, we want to know how much is in 1 serving. So we just do 4.5 divided by 3, and you get 1.5 per serving. Third one, 12 runs in 5 innings, find the unit rate. So in other words, how many runs per inning, per 1 inning? So we divide 12 by 5, and we get 2.4 runs per inning. All right, a little more complex on number 4. You're going to have to find a unit rate and then use that to solve the rest of the problem. So your basic monthly charge for cell phone service is $30. That includes 300 free minutes. You pay a fee for each extra minute you use over that 300. One month you pay $3.75 for 15 extra minutes. Find the total bill if you use 22 extra minutes. So first we're going to have to find that unit rate. What is it per extra minute? So we have $3.75 for 15 extra minutes. So if we divide that, we are going to get 25 cents per minute. So we know we have a $30 basic charge, and now we know we have 25 cents per minute, and they want to know for 22 extra minutes. So there's what we're simplifying. So if we can just type that into our calculator, 30 plus 0.25 times 22. And you get a bill of $35.50. Okay, so that is unit rate. Okay, you might also be asked to find rate of change for a given scenario. It's just the same as finding rate of change slope from a table as we've seen before. It's just now the table has a description of what it's representing. So the table shows the cost of using a computer and internet cafe for a given amount of time. Find the rate of change in cost with respect to time. So here's our y's. Change in y is up 7. Change in x, up 2. So 7 divided by 2, and it's okay for these to go ahead and turn into a decimal. It makes more sense. 7 divided by 2, we get 3.5. So it's $3.50 per hour. Okay, the next one, table shows the distance a person walks for exercise. Find the rate of change with distance with respect to time. So our change in y here is up 1.5. Our change in x is up 30. So 1.5 divided by 30. 1.5 divided by 30, and we get 0.05. So you're going 0.05 miles per minute. So that is using finding rate of change, just like we've done it before from a table. It's just like I said, now it's representing a scenario in that situation. All right, turn it over. Last thing we're going to look at is just interpreting graphs. And what I want you to do is skip down to actually the very last one. That's the main one we're going to look at today. This would be what I'd expect you to be able to do, to look at something like this and interpret the meaning. So this says a student commutes from home to school by walking and by riding a bus. We're going to describe this commute in words. So it looks like our y-axis is the distance they've traveled. X-axis is the time. So for this first part, I'm going to call it section A. He's taking quite a while, quite a little bit of time to travel a short distance. We could assume between walking and riding the bus, this must be when he is walking. Part B, I'm going to call this section. In this section, time is passing, but he's not going anywhere. So he's walked. We're still waiting to ride the bus. So it could be assumed that he is waiting at the bus stop. Waiting on the bus, something to that meaning. And then part C, very little time has passed and we've gone a great distance. So now he is most likely, or he or she, most likely riding the bus. So that is how we could interpret the meaning behind a graph. Okay, so this was slope and rate of change, part 2.